Okay, so I hope the other video helped you to understand what logarithm is, and for using for uh, the real life application. So this is another one. It's like example 7. Before example 7, let me read application. One method of determining how the x and y value for the set of nonlinear data are related is to take the natural logarithm of each of the x and y values. Okay, if the points when graphs fall on a line, then you can determine that the x and y value are related by the equation of natural log y equal m. M is usually a slope of natural log of x. Okay, where m is the slope of the line. So it's okay. So example 7 is finding the mathematical model. Okay, the table shows. So this is a hint. So they give you usually if they show the curve, or if there's a pattern of the usually in the real world we use the scatter plot. Okay, for AP stats class, maybe student might be familiar with scatter plot with a different pattern, and you have to convert to something we can see the linear relationship. So the one of the way is you convert natural log to both y and x, sometimes only one of them, to change to natural log or log, or it could be reciprocal or squared or square root function. Is just you're going to play around to make it to scatter plot to make it the straight line. Okay, but this one they give you how to do it already here. So natural log of y and natural log of x, but there's m carries on. So let's think a little bit on this using example 7, finding a mathematical model. The table shows the mean distance from the sun, x, and the period y, which is the time it takes a planet to orbit the sun. So look at Earth, it's 1, mean distance is 1. They consider that as that is 1, and orbit it's 1, which is 1 year to go around the sun, and for us, right? So if you're in Jupiter or Mars, it's going to be different orbit. Okay, so so they research on the 6 planets right here, and there's a table here. So tables shows the mean distance from the sun, x, and the period y. The time it takes a planet to orbit the sun. For each of the 6 planets that are closest to the sun, right? In the table, the mean distance is given in terms of astronomical units, where Earth is the mean distance defined as 1, and the period is given in the years. Oh, period is given, yeah, it's 1, that's why 1 year, right? So find the equation of the rate y and x. So what you have to do is you have to open TI calculator. You might not have it, but just if you have it, just change this, convert this one to, convert everything to natural log. So I will open, let me share. I will open this one, and I will open the note. Where's the note? Maybe I will share the whole screen instead. So let me share the whole screen. Okay. Okay, this is my whole screen. Now you see my note and this information. So if you use natural log, the first number you plug in is, let's plug in natural log of 1, which is Earth, Earth's distance from the sun, right? So if that's our distance defined as 1, so log base, so base is a natural number, if it's e to what power is 1? So it must be 0. Yeah, so this is 0. So if you if you convert this one to natural log, it's going to be 0. Same thing about this number, right? So how many years orbit the sun, planets orbit the sun. So Earth is 1 year. So this is going to be 0. Natural log value is 0. So if you do, let's think about Mars. So if you Mars, you plug in natural log of 1.524. That is distance, right? So instead of 0, the distance from the sun is 0.42 natural log value. Okay. How about how many years of it? It's 1.8 years, 1.88 years for Mars. But if you consider that as a natural log, you plug in, just not a second, natural log. Let me see. Oh, sorry, what did I do? Yeah, on and off, maybe on and off, sorry. What did I do? Yeah, clear. Okay, so let's go, come back to this one. So natural log is this, and I enter 1.881. That is right here. I'm just only doing the Mars. So let me cut and paste here. Let's see, this number will correspond. So let me cut and paste to next page. This is a table that textbook calculated for you. So this I did is Earth, of course. Earth is 0, 0. So let me see. Let me highlight Earth with sky blue. 0 and 0. Okay. Now, Mars, so a little bit reddish color, right? So it's maybe orangish color. I would change to orange highlight. 0.42 and 0.63. Okay, those are Mars. Okay, and if you plug everything in to natural log, this becomes straight line right here. Now they're asking for what kind of linear information. So they calculated here. They use Mars, example, Mars to Earth. Mars is this color, Earth is this color. So it came up around 1.5, this is 3 over 2. So you can rewrite the equation. So y, natural log of y, and write down natural log of y is where is it? Natural log of y can be explained. I would say it's if it's they say can be explained for AP Stats class. So it's in natural log of x, but what is the m with the slope? So I put the 3 over 2, which is 1.5, right? And going to like this. And erase this part. Okay, so this is it. So this is the final answer for this example 7. Okay, I hope you understand. If you have any question, please text me or please email me, and I will create the video for you during the break. And I hope you have a nice and safe break. And this is last asynchronous. Have a nice weekend.